Hello and welcome to Saurabh Sir's classes. Today we are discussing the IIT JAM 2020 Mathematical Statistics paper. Now in this question we are given let alpha and beta be two real numbers and the expression this one limit extending to 0 is equal to beta, and we are asked to find the value of alpha plus beta. Now for very small x or x tending to 0, we can write sin x approximately equal to x and tan x also approximately equal to x, because these are very small values and both the series of sin and tan will almost be equal to x for very small values of x. So using this we can write this as beta equal to limit x tending to 0. In the numerator we have tan 2x, that can be written as 2x, and then we have 2 sin alpha x, which can be written as minus 2 alpha x, and in the denominator we have x, and 1 minus cos 2x can be written as 2 sin square x, 2 sin square x, which is equal to limit x tending to 0 2x into 1 minus alpha in the numerator, and in the denominator we have x, and instead of sin x I can write x again, so 2x square. So now I can simplify this and get 1 minus alpha over x square, limit x tending to 0. This is equal to beta. So therefore we can see that the numerator is a constant term. So we can rewrite this as 1 minus alpha is equal to beta into limit x tending to 0 x square. So therefore if we put the value of x equal to 0 here, this becomes 0. So alpha is equal to 1. So we got the value of alpha now. Now we have to find the value of beta. So in order to find the value of beta, we have to actually find the limit of the function. Now we notice that the function is of the form 0 by 0. Why? Because tan 2x is 0 at x equal to 0, sine of alpha x is 0 at x equal to 0, and we have x in the denominator, so this makes it in the form 0 by 0. And whenever we have it in this form, we apply L'Hospital's rule. That means we'll have to differentiate the numerator and the denominator. So then we can write beta is equal to limit x tending to 0. Differentiating the numerator will give us differential of tan 2x, which is 2 sec square 2x, minus differential of 2 sin alpha x, so which is 2 alpha cos alpha x, and we differentiate the denominator, so differential of x is 1, so 1 into 1 minus cos 2x, 1 minus cos 2x, plus x into differential of 1 minus cos 2x is 2 sin 2x. So we got the differential, but even after getting the differential we are still stuck with the problem of having a 0 in the denominator. Now how do we proceed from here? So first of all, we have found the value of alpha equal to 1, so let's put that here. So beta is equal to limit x tending to 0 2 sec square 2x minus 2 cos x divided by 1 minus cos 2x will be 2 sin square x plus 2x into sin 2x, sin 2x. So now we remove the common factor, which is 2, in both numerator and denominator. So we can simplify this. Limit extending to 0, sec square 2x minus cos x over sine square x plus x sine 2x. Now we can write sec square 2x as 1 plus tan square 2x. So we can simplify this. Limit extending to 0, 1 plus tan square 2x minus cos x over sine square x plus x sine 2x. Now we can write 1 minus cos x. 1 minus cos x, we can take this and write this as 2 sine square x by 2. We can do that. So then the expression becomes equal to limit x tending to 0. We take 1 minus cos 2x as 2 sine square x by 2. So 2 sine square x by 2 plus tan square 2x over sine square x plus x sine 2x. Now we will again apply the logic of sine x is equal to or roughly equal to x for x tending to 0, and tan x is also equal to x for x tending to 0. So therefore we can write this as equal to limit x tending to 0. 2 sine square x by 2 means 2 sine x by 2 whole square, or instead of sine x by 2 we'll write only x by 2, so x by 2 whole square plus tan square of 2x. Tan square of 2x means tan of 2x whole square. So instead of tan of 2x, we'll write 2x whole square. And in the denominator, instead of sine square x, we'll write x square plus x into sine 2x, we'll replace it with 2x. So this becomes equal to limit x tending to 0, 2x square by 4 plus 4x square over x square plus 2x square is 3x square. So this is nothing but limit x tending to 0. We can cancel out the x squares. So 2 by 4 is half. So half plus 4 by 3, which is not dependent on x anymore. So we don't need this. So this would be 4.5 means 9 by 2 over 3. So we can cancel 3 and 9 and we get 3 by 2. So this is equal to 3 by 2. So that means beta, which was the limit of the function x tending to 0 that we started with, comes out to be 3 by 2. And we already found the value of alpha as 1. So alpha plus beta will be 3 by 2 plus 1, which is equal to 5 by 2. So option D is the correct answer.